Now in class 12th, I am taking a topic, the electric cell. You have heard the name of the electric cell also in the previous classes, like your 10th class and that the 9th class. But here this will study in some detail of this electric cell. The device which converts chemical energy into electrical energy is called electric cell. Electric cell. Since this is the conversion of chemical to electrical, so what we have? Chemical energy converts into electrical energy. Electrical energy. The chemical energy is stored in the cell when the reaction takes place. So there is the redox reaction. It means the reduction and oxidation takes place in the cell, and because of that the chemical energy is stored. When the electrodes are connected to some resistance, then the current flows in the outer circuit. It is also called electrochemical cell. Now this cell has, suppose we are having, this is a cell, this is suppose N, this is the electrode, this is now a resistance R, and this we have what we have. This is now your positive and this is negative. So these are the electrodes. This is the negative electrode. It is positive electrode. Positive electrode or anode. It is called negative electrode. Negative electrode or cathode. This is the electrolyte. Electrolytes. So this cathode and anode are made of some metal. This is an electrical circuit and this is the container. It is continued. So this the current flows through this one. The current in the outer circuits. The current in outer circuit flows from anode to cathode through the electrical wires. Connecting wires, while current inside the cell flows from cathode to anode and is carried by ions in electrolytes. तो बाहर जो करंट फ्लो होती है वो तो दिस फ्रॉम एनोड टू कैथोड, बट इनसाइड दिस electrolyte the current flows from cathode to anode. So this is no flow of the current like this. This flows in this way, and this current is carried by the anion and cation. So anion and cation, these are the ions which have the positive and negative charge, but current flows in the one direction, that is from cathode to anode. When no current is taken from cell, the electrolyte is at same potential at each point. तो क्या जब हम सेल से करंट ड्रॉ नहीं करते हैं तो इन दैट केस द इलेक्ट्रोलाइट इज एट द इक्वल पोटेंशियल, सो द पोटेंशियल एट एवरी पॉइंट इज इक्वल. Now we talk about the electromotive force. Electromotive force. When cell is in open circuit. Open circuit means that no current is taken from the cell. It is an open circuit. The potential difference potential difference between electrodes is called electromotive force. Electromotive force, this is not a force, but this is the energy which is supplied to the current carriers in order to flow the current. EMF is no more a force, but it is the energy supplied by cell to current carriers It is the energy supplied by the cell to current carriers to flow the current. To flow the current. So what we have that let B1 equal to potential of anode and B2 equal to potential of cathode, and let V is equal to potential of electrolyte. Now this B1 is more than V and B2 is less than V. Here B1 is greater than V and B2 is less than V. B2 is negative, this being at the cathode. So this B2 is negative, this is positive. So now what we have? Therefore, potential difference between electrodes. This is equal to, this B is more than V, so this is now B1 minus B minus, now this B2 is less than V, so what we have? This is your V minus B2, V minus B2, because V is more than this B2. So we are having the potential difference between the electrode and cathode and that of the electrolyte. Then this will be equal to how much? B1 minus B plus V1 minus V, potential difference between this and potential difference to this and this. So now we have to take the sum of these two. Then this will come out to be negative. So this is now this is being negative. B2 is negative. So what we have to take here? This is your this we take minus B2 and minus B. This will be not so much. Minus B. This is taken to be negative 1. Then this is the minus minus, this will now plus B2, and this is now your plus B. So plus B and minus B will cancel. So we will have this B1 plus B2. This is now E. This is denoted by this one. This is the EMF. It is EMF. EMF of cell. So just to find the EMF of cell, what we have to take? That just to add the potential differences of the potential of the electrode and of the both the electrodes. Suppose this is at potential, this cathode, anode is at potential, suppose plus 1. This is now at minus 1. Then plus 1 and minus 1. Just keep separate. Then you will get this B1 plus B2. So that is equal to 1 plus 1. That is 2 volt. So the unit of this EMF, that is equal to volt. Unit of EMF. This is now volt. Volt or joule per coulomb. This is also joule per coulomb. So we also define the electromotive force as the work done to carry a unit positive charge throughout the circuit along with the cell. The electromotive force EMF is defined as work done in carrying a unit positive charge throughout the circuit along this cell. Along this cell. So this is what the meaning of this EMF of this cell. And this EMF is always greater than the terminal voltage of the electric cell. And now we have the terminal voltage. Terminal voltage. When current is taken from cell, or current is taken from the cell, or the cell is in closed circuit. The potential difference across the electrodes cell is called terminal voltage. Is called terminal voltage, denoted by V. It is the potential drop across the external resistance. When the current is taken from the cell, the potential difference across the electrodes of the cell is called the terminal voltage. It is the potential drop across the external resistance. तो मैंने अभी आपको सर्किट दिखाया था, उसमें एक्सटर्नल रेजिस्टेंस R लगा हुआ था, तो ये V इक्वल टू क्या होता है? V इक्वल टू IR, and this V is less than the electromotive force. It is less than EMF. And now internal resistance. R. What is this internal resistance? When the current passes through the electrolyte, the current carrier faces the resistance due to the electrolyte. That is called the internal resistance of the cell. It is the resistance offered inside the electrolyte to flow the current so it is called internal resistance. Internal resistance denoted by R. Denoted by R. तो क्योंकि ये सेल के अंदर होता है इसीलिए हम इंटरनल रेजिस्टेंस कहते हैं। अब सेल के अंदर कहाँ से आता है? तो जब उसमें आयंस होते हैं वो फ्लो करते हैं, तो फ्लो करते समय जो इलेक्ट्रोलाइट होता है वो उसमें एक रुकावट पैदा करता है और रेजिस्टेंस ऑफर करता है। तो ये जो रेजिस्टेंस ऑफर करता है इसी को हम कहते हैं इंटरनल रेजिस्टेंस। The potential drop occurs due to internal resistance. So potential drop कितना होता है? Now this potential drop, this is equal to I. So now what we have? When the cell is in open circuit, closed circuit, let cell is in क्लोज सर्किट, मान लो क्लोज सर्किट में होता है तो क्या होगा? दिस V is equal to E minus I. This terminal voltage is equal to E minus IR. This is in accordance with the law of conservation of energy. It is in accordance with law of conservation of energy. So when the cell is providing the current, then this terminal voltage is equal to the difference of the electromotive force and the potential drop across the internal resistance. So this IR is called the potential drop across the internal resistance. For ideal cell, R equal to 0. तो हम आइडियल सेल उसे कहते हैं जिसका इंटरनल रेजिस्टेंस 0 होता है, R equal to 0. So V is equal to E. तो अगर आइडियल सेल की अगर उसका इंटरनल रेजिस्टेंस होगा ही नहीं तो पोटेंशियल ड्रॉप नहीं होगा. When there is no potential drop, then the terminal voltage, this terminal voltage is always equal to the EMF of the cell. So these two are always equal. So then this I is equal to this to be now so much, and here I have told you that this potential difference is across the external resistance. So this is equal to I into R. So if you put this value V equal to I into R in this relation, then what will you get? Current putting V equal to IR here in this. So what we have is IR is equal to E minus IR. So here we have this I, R plus R, this is equal to E, and here this I is equal to E upon R plus R. This is now current. So much current will be provided by this cell. If R is equal to 0, then you can see that this I is maximum. So for maximum current, for I maximum R equal to 0. So this I maximum, this is will be equal to E upon R. This is not so much. So when the cell is ideal or we are having a cell of very low internal resistance, in that case we can neglect the value of small r, and in that case the current will be provided at a large amount for a long time. This is why so many cells are made in such a way that their internal resistance is very low. And This is when the cell is in the closed circuit. If suppose or we can say that the cell is providing the current. Now if this is charged, if the cell is charged, and in this case we are having this V less than E, V less than E. So what we have? When cell is charged, cell is charged, then we have this V equal to E plus I. E plus I. Now the terminal voltage is greater than E. Now V greater than E. So when the cell is charged, then this terminal voltage is more than the EMF of the cell. This terminal voltage is now the voltage of the charging device. The terminal voltage is the potential of charging device or charger. जो चार्जर होता है या चार्जिंग डिवाइस होती है उसका ये ईएमएफ होता है। अभी टर्मिनल वोल्टेज उसके ईएमएफ के बराबर होगी। अब आप इसमें देख सकते हैं कि ये चार्ज तभी होगा when the V is more than the EMF of the cell. अगर इससे कम होगा तो फिर चार्ज नहीं होगा, फिर तो क्या उल्टा डिस्चार्ज होना शुरू कर देगा। तो ये इसमें आपका इलेक्ट्रिक सेल के बारे में है कि जब हम उसको ऑपरेट करते हैं तो इसमें क्या होता है, उसके अंदर किस तरह से करंट फ्लो होती है। तो always remember that in the outer circuit the current is carried by the electrons in the connecting wires, and in the inside the electrolyte the current is taken by the ions. They are the cation and the anion. When the cell is operated, then the terminal voltage is always less than the electromotive force, and when the cell is charged, then the terminal voltage is more than the EMF of the cell, and that the internal resistance that is offered by the electrolyte when the ions move in the electrolyte. So this is about the electric cell. In addition to this one, we have the electrochemical cell, but there are some other cells also, like the photovoltaic cell and the photocell, or they are also called the solar cells. There is no electrolyte at all, but there is the conversion of the electrical the light energy into the electrical energy. So they are very useful and they are very light one in that case. Now I am telling you to this also. The photocell or photovoltaic cell converts the light energy into electrical energy. Electrical energy. So what happens here that this light energy converts into electric energy. So this is all about the cell. Thank you very much.